You're welcome back. In today's video, I want to explain eigenvalues and eigenvectors and how we can find them. If you could remember when we were doing sets of linear equations, where we used matrix method, determinant method, which is also known as Cramer's rule, then Gaussian elimination method, you see that those equations, those simultaneous equations, we said that we are going to write them in a matrix form. So if you write them in matrix form, we always arrive at AX is equal to B. So where A is a square matrix and B, X here is a column matrix and B is also a column matrix. So what this means is that for every square matrix, there is always a special vector beside it. So this is the vector here, X. So it is special in the sense that if you multiply the square matrix by it, you are still going to get a column matrix. What I'm saying is that if you multiply a square matrix by this column matrix, you are still going to get a column matrix. So that means this is special. So if this is special, that means I can write B to be equal to lambda x. So the main equation here can now be written as Ax is equal to lambda x. So if this happens, from here I can multiply the right hand side here by what? An identity matrix. So if I multiply by an identity matrix, so I can say that Ax minus lambda xi is equal to 0. Why do I multiply by an identity matrix? If I multiply any matrix by an identity matrix, I'm going to get that matrix back. So it doesn't have effect on it. So here I can factorize x out. So I have a minus lambda I, then multiply by x is equal to 0, which can later be written as a minus lambda I is equal to 0. So from here, if we are asked to find eigenvalues and eigenvectors of any square matrix, you are going to find the eigenvalue first. So which one is the eigenvalue here? Which one is the eigenvector here? So x is the eigenvector. You know, I told you it is a special vector, so it is called the eigenvector. And this lambda is what? The eigenvalue. So x is the eigenvector, lambda is the eigenvalue. How do we now find the eigenvalue and the eigenvectors? For you to find the eigenvalue and the eigenvectors of a square matrix, you have to follow these steps. Step 1 is that you have to multiply an identity matrix by the scalar. That is, you multiply identity matrix by a scalar, means you have I multiplied by lambda, which can be written as lambda I. That's the first step. So step 2, step 1 is lambda multiplied by I. Step 2 is that subtract step 1 from matrix A. So that means this is step 1, we want to subtract it from matrix A. So step 3, find the determinant of matrix gotten in step 2. So 3, you are finding the determinant of A minus lambda I. Step 4, equate step 3 to 0. That is, determinant of A minus lambda I is equal to 0. Step 5, solve for the values of lambda that satisfy equation 4. Then step 6, solve for the corresponding eigenvectors of each lambda. So let's solve this example for us to understand it better. Find the eigenvalues and eigenvectors of the matrix A is equal to 7, 3, 3 minus 1. So the first step is to multiply lambda by the identity matrix. So the order of A, Miriam, job. Solution. So let's follow all these steps. The first step is that I want to multiply an identity matrix by the scalar. So that would be lambda multiplied by I identity matrix. The order of this identity matrix will be determined by the order of the given matrix A. So this is 2 by 2 matrix. That means this identity matrix must also be 2 by 2 matrix. So here, my I identity matrix will be 1, 0, 0, 1. So lambda multiplied by 1, 0, 0, 1 will now be equal to, you use lambda to multiply all the elements there. So I have lambda multiplied by 1 is lambda, lambda multiplied by 0 is 0, lambda multiplied by 0 is 0, lambda multiplied by 1 is lambda. So now, after doing this, let's go to step 2. Step 2 says that subtract step 1 from the matrix A. So step 2, that is A minus lambda I. So what is matrix A? Matrix A is 7, 3, 3, minus 1. So minus lambda I. Lambda 0, 0, lambda. So this one gives me 7 minus lambda, 3 minus 0, that is 3. 3 minus 0, that is what? 3. Minus 1 minus lambda, that is what? Minus 1 minus lambda. So I've gotten my A minus lambda I. Step 3. Find the determinant of the matrix gotten in step 2. Here is the matrix gotten in step 2. So step 3 says that we need to find the determinant of A minus lambda I, which will be 7 minus lambda, 3, 3, minus 1 minus lambda. It's determinant. So to find the determinant of 2 by 2 matrix, you multiply the elements in the leading diagonal together. So I have 7 minus lambda multiplied by minus 1 minus lambda. Then you multiply elements in the second diagonal, which will be 3 multiplied by 3, and that is 9. So here I have 7 multiplied by minus 1, that is minus 7. 7 multiplied by minus lambda, that is minus 7 lambda. Minus lambda multiplied by minus 1, that is what? Plus lambda. Then minus lambda multiplied by minus lambda, that is plus lambda squared. So don't forget this 9, minus 9. So here is equal to minus 7. Minus 7 lambda plus lambda, that is minus 6 lambda. Minus 6 lambda plus lambda squared minus 9. So let's collect like terms. Minus 7 minus 9, that's minus 16. So minus 16 minus 6 lambda plus lambda square, that is my determinant of A minus lambda I. So step 4, equate step 3 to 0. So step 4, equate step 3, step 4. So that means determinant of A minus lambda I equals 0. I want to equate it to be equal to 0. So this will be minus 16 minus 6 lambda plus lambda squared is equal to 0. So let's rewrite, let's arrange. So I have lambda squared minus 6 lambda minus 16 is equal to 0. This is a quadratic equation. So from here, you know that we have three methods to solve quadratic equation. We have factorization method, we have completing the square method, and we have formula method. So let's check if this one is factorizable. So I need two factors of minus 6 lambda. So if I add together, I'm going to get minus 6 lambda. If I multiply, I'm going to get minus 16. So that will be minus 8 lambda plus 2 lambda. So minus 8 lambda plus 2 lambda will give me minus 6 lambda. Minus 8 lambda multiplied by plus 2 lambda will give me minus 16 lambda squared. So that is what I want. That is, take this with its coefficients multiplied by the constant here. I have what? Minus 16 lambda squared. Then I need minus 6 lambda. So I need two factors of minus 6 lambda, that if of factors of minus 16 lambda squared, sorry. If I multiply together, I'm going to get minus 16 lambda. If I add or subtract, I'm going to get minus 6 lambda. And that is minus 8 lambda plus 2 lambda. So from here, my lambda square minus 8 lambda plus 2 lambda minus 16 is equal to 0. So here I have lambda into brackets lambda minus 8 plus 2 into bracket lambda minus 8 is equal to 0. So from here I have lambda plus 2 into bracket lambda minus 8 is equal to 0. So from here, my lambda plus 2 is equal to 0, or lambda minus 8 is equal to 0. So from here, my lambda 1 is equal to minus 2, and lambda 2 is equal to 8. So that means my eigenvalues are minus 2 and 8. So I've gotten the eigenvalues. So for eigenvectors, so let's write back the equation. Ax is equal to lambda x. So we want to find x. So from here, my a seven multiplied by x1, that will be 7x1 plus 3 multiplied by x2, 3x2 is equal to, if I multiply this one, that will be minus 2 multiplied by x1 is equal to minus 2x1. So here, maybe we do this one first. It will be minus 2x1 minus 2x2. So let's do for this one. So 3 multiplied by x1, 3x1, minus 1 multiplied by x2, minus x2 is equal to minus 2x2. So from this first equation, I can say that let's minus 2x1 go and meet 7x1. That is, I want to collect like terms. So I have 7x1 plus 2x1. So let's 3 plus 3x2. Let it come out now. So I have minus 3x2. So from here, I have 7x1 plus 2x1 gives me what? 9x1 is equal to minus 3x2. So from here, I can divide both sides by 3. If I divide both sides by 3, I have 3 here, 1, 3 here, 3. That will be 3x1 is equal to minus x2. So from here, I can divide both sides by x2. If I divide both sides by x2, I have 3x1 divided by x2 is equal to minus 1. So I can still divide both sides by 3. So that means I have 3x1 divided by x2 is equal to minus 1 over 3. So 3 cancel 3. So I have x1 over x2 is equal to what? Minus 1 over 3. So here it means that my x1 is equal to minus 1 and my x2 is equal to 3. So from here, I can say that when my eigenvalue is equal to minus 2, when lambda 1 is equal to minus 2, then x will be equal to, this is x1, x2 is equal to what? Minus 1 and 3. So that is how to find the eigenvectors. So what I performed there is like a ratio. If I say that x1 ratio x2 is equal to minus 1 ratio 3, this will be x1 over x2 is equal to minus 1 over 3. So that is what I performed there. So now, when lambda 2 is equal to what? Lambda 2 is 8. Let's see what happens. So I have ax is equal to lambda x. So this will be 7, 3, 3 minus 1, x1, x2 is equal to, anywhere I see this lambda, I'm going to put 8, then x1, x2. So this will be 8x1, 8x2. So let's multiply. 7 multiplied by x1, that will be 7x1 plus 3 multiplied by x2, that will be 3x2 is equal to 8x1. So I also have 3x1 minus x2 is equal to 8x2. You can either pick the first equation or the second equation. They are still the same thing. So let's take equation 2 here. So let's collect like terms from equation 2. I have 3x1 is equal to 8x2 plus x2. So 3x1 is equal to 9x2. Divide both sides by 3. So here I have x1 is equal to 3x2. So you can easily know the value of x1 and the x2 here. The coefficient of x2 will be the value of x1, and the coefficient of x1 will be the value of x2. You can do it, or you can also do it like this: divide both sides by x2. That will be x2 will be equal to 3. So then it's still over 1. So that means my x1 is equal to 3 and x2 is equal to 1. So from here, I can say that when lambda 2 is equal to 8, then x is equal to x1, x2 is equal to 3 and 1. So that is how to find eigenvalues and eigenvectors of a square matrix. The first thing is that you multiply the scalar by the identity matrix. Then that is the first step. Step 2 is that you now take matrix A minus lambda R. After that one, you find the determinant of A minus lambda I. Then you later equate like determinant of A minus lambda I to be equal to 0. Then you use that one to find lambda, which will be our eigenvalues. So after finding the eigenvalues, you can now apply it to find, you apply it into the initial equation ax is equal to lambda x to find the values of your x, that is the eigenvectors. So if you follow these steps, you see that to find your eigenvalues and eigenvectors is very, very simple. See you in the next class. Thank you. Bye bye.